All right, solve a radical inequality. Well, there's three things we're going to need to do. First thing we need to do is, and this is part of the expression, the square root of 2x plus 2 in this particular inequality. In other words, what's underneath the radical? And it is an even radical. It's the square root. And so I can't have anything that's going to cause me to try to take the even root, in this case the square root, of a negative number. You'd agree with that, correct? Because that would be an imaginary number, and we're dealing with real numbers. Now, if it was an odd root, it wouldn't matter. It could be negative. That'd be okay. I wouldn't have to take this step. But since this index here is 2, as an even number, square root of, I have to first find what would cause this part of the expression to be something less than 0, where I can't take the square root of the negative number. Second, I solve the inequality itself. And then third, we establish a number line, and we set test points, and our test points are going to come from where our solutions are, and we're going to test those test points to see if it gives us a true statement to finish and finally determine what is our solution set. Remember, when we got inequalities, we have sets of solutions, not just a solution. So let's take what's underneath the radical, and we're going to set that up as 2x plus 2, and that must be greater than or equal to 0. And we're going to subtract 2 from both sides, so we got 2x now is greater than or equal to negative 2, and divide by 2. So x must be greater than or equal to negative 1 to satisfy what is underneath the radical. So that is going to be one of my test points, negative 1. X greater than or equal to negative 1. Now I'm going to the second step. Second step is I'm just going to solve the inequality. So we've got the square root of 2x plus 2 and then plus 1 greater than or equal to 5. I'm going to subtract 1 from both sides, so we got the square root of 2x plus 2 is now greater than or equal to 4. 5 minus 1 is 4. I think you'd agree with that. Then we're going to square both sides of this inequality to get rid of the square root, leaving me with 2x plus 2 greater than or equal to, and 4 squared is 16. And now we're going to subtract 2 from both sides, so we got 2x is greater than or equal to 14, and divide by 2 so that x, second test point, being greater than or equal to 7. Now I'm going to set up a number line, and I'm going to put my 2 test points on there. I got negative 1, and then I've got 7. And so I've got 3 intervals to test. And so I can test any number first that is that's less than negative 1. Well, if I just stop and think about that, if x has got to be greater than or equal to negative 1, it wouldn't matter what number I put less than negative 1, it's going to cause that radicand to be negative, and I can't take the even root of a negative number. But we'll do one anyway. How about negative 2? If I substitute negative 2 for x, I got 2 times negative 2, well, that's negative 4. Plus 2, negative 4 plus 2 is negative 2, and boom, that interval fails. I don't even have to finish solving. Now, let's take a test point between negative 1 and 7, and let's see if that passes or fails. And an easy one is 0. 0 is between negative 1 and 7. And so if I put in 0 for x, I got 2 times 0, square root of 2 times 0. Well, 2 times 0 is 0, plus 2. So we've got the square root of 2 and then plus 1, and we're asking, is that greater than or equal to 5? Well, let's see. If I put in the square root of 2 plus 1, rounding to the nearest hundredth, that's 2.41. Well, 2.41 is not greater than or equal to 5. I think we can all agree on that. So that interval fails. And now we're going to go and test this interval, something greater than 7. And I can pick any number greater than 7. And by the way, I should put closed dots here and closed dots here because these are greater than or equal to. Let's pick 8. So let's see. Now we got the square root of 2 times 8 plus 2. Well, let's see. The square root of 2 times 8, that's 16. Plus 2, that's 18. Square root of 18 plus 1, is that greater than or equal to 5? And I'm just going to pull my calculator out, and I'm going to put the square root of 18 plus 1. And rounding to the nearest hundredth again, that comes to 5.24. Well, 5.24 is greater than or equal to 5. And so this interval is going to pass. Thereby giving me a solution set that x must be greater than or equal to 7. Any number greater than or equal to 7 is going to give us a true statement on that inequality. Are you ready to look at another one? Raise your hand if you're ready to look at another one. Oh, I see those hands. Everybody's hand went up. Oh, that's great. Let's look at one. All right, so now we got the square root of 4x minus 4, and then minus 2. Question being, is that less than 4? So what's step 1? Step 1 is I'm going to deal with that radicand. And I'm going to set that as 4x minus 4, and it must be greater than or equal to 0. Well, let's add 4 to both sides. So we got 4x is greater than or equal to 4. Then we're going to divide by 4. So here we got a test point being x is greater than or equal to 1. Let's go ahead and draw a number line. So I got a number line out here. Well, I'm going to wait and fill it in because I'm not sure what else is coming. Now let's solve the inequality itself. So we got the square root of, let me block that off. We got the square root of 4x minus 4 minus 2 is less than, and it's a simple less than, 4. All right, let's add 2 to both sides. So now I got the square root of 4x minus 4 must be less than 6. Can we agree on that? Adding 4 to both sides. Now let's square both sides of the inequality. And so it's going to leave us with 4x minus 4 being less than, let's see, 6 squared is 36. Okay. And we're going to add 4 to both sides. So now we got 4x is less than 10. Oh, excuse me, 40. I'm getting ahead of myself. 40. And when we divide by 4, we're saying 4x, x must be less than, just a simple less than 10. So there's my second test point. All right, let me get, so I got my number line. Let's go ahead and put 1 out here with a closed dot because it must be greater than or equal to 1. But I got an open dot here at 10 because that's just a simple less than. All right, so let's test our intervals. Well, 0 is less than 1, right, on this interval right here. Well, 4, let's see, square root of 4 times 0, 4 times 0 is 0. Then I'd end up with the square root of negative 4. Well, none of this thing less than 1 can work, which I've already really stated there when I solved what was underneath the radical. Now I've got an interval between 1 and 10. Let's choose 5. 5 is between 1 and 10, right? So I'm going to substitute 5 for x. So we got the square root of 4 times 5 minus 4. 4 times 5 is 20. Minus 4 is 16. So I got the square root of 16 minus 2 being less than 4. And the square root of 16 is 4. So 4 minus 2 is 2. And 2 is indeed less than 4. And so that interval passes. And then I just want to be sure. So I'm going to test an interval beyond 10. I don't know. Let's choose 12. All right, so I got the square root of 4 times 12 minus 4, then minus 2. Is that less than 4? Well, let's see, we said 12. So I substitute 12 for x. So 4 times 12 is 48, minus 4, that's 44. So I got the square root of 44 minus 2, and I want to know, is that less than 4? Well, let's see, I got the square root of 44 minus 2. What does that come to? That comes to 4.63. Well, 4.63 is not less than 4, and so that interval fails. So now what's my solution? I can say that x must be less than or equal to x, and x then has to be less than 10. So let's read it another way. X has got to be greater than or equal to 1, but it's also got to be less than 10. And Shazam, there is my solution set, and we have solved a radical inequality. Got to do those test intervals, people. That's the key.